Yeah. Okay. So welcome to this session for sorry. ME174 Lab 2. So right now we're going to be tackling QBlade. Um QBlade is a QBlade is a simulation software. It's a modeling software for specifically wind turbines. Hindi lang horizontal axis but also vertical axis. Right now mag-horizontal lang muna tayo. Pero if after yung following sessions natin, feel nyo comfortable na kayo galaw-galaw sa QBlade, you can try the vault options for QBlade. So, right. So, ngayon, ito yung outline natin for this morning or rather this high noon. Magre-review lang tayo ng konti sa airfoil terms. Tapos, we'll talk about QBlade, yung konting background lang niya, and mag-activity tayo. Sa activity na 'to, I'm not sure if since konti lang kayo nakapag-download pa, this will be submitted ano na lang, like after today. Pag-isipan ko pa kung kailan, pero, siguro mga this week lang. It's not gonna be too hard naman. So, okay, disclaimer, yung exposure ko sa QBlade is just during the ME171 subject. So for yung professor namin nun was Sir Louis Danao. If meron sa inyo nagsi-CFD na ME200, maybe you've heard of his name. Um, basically, hindi, recorded pala to. So, like, no. So, yeah, medyo sobrang gaan lang. I would say na mas magaan yung pag-tackle niya ng Keyblade compared to this. Pero yeah, that's what gives me the confidence na although medyo magaan lang yung pag-tackle natin dun sa components niya, I think that will be enough to get you comfortable with moving within the software. And if you get comfortable enough, you can start to explore or parang explore what makes it tick at least. Just to help you understand kung ano yung difference niya with in comparison to ANSYS. So, ang maganda sa Keyblade is that it's very accessible. Maraming tao ang gumagamit ng Keyblade sa academe, pati sa industry. Meron akong kabatchmate nag-master siya sa Europe. He was able to use Keyblade for his European thesis. So, yeah, speaks to the volumes of this software. So, yung mga other parameters, siguro it can be a little overwhelming. Pero if ang maganda sa Cubase is that yung default settings niya, it's kind of sitting at the good zone naman. So, if hindi mo pa masyadong kapa yung mga theorems, yung mga formulas na hanash ng mga wind turbines, if you sit inside the default settings ng QBlade, as you can make a decent enough na simulation out of it. So, okay, let's review. Okay, sino sa inyo NSI 16 sa akin nung mid-year? Meron ba sa inyong hindi nag-NSI 16 sa akin? Yeah, I'm curious. Okay, okay. So yeah, oo nga pala. Kaya yung mga Smurf nung mid-year, ano? I remember that. It's okay. That's all right. Ngayon, dadaanan lang natin yung pahapyaw na dinaanan ko rin sa 16. So, yung thing that's absent in 16 is yung lift drag characteristics, especially for aerodynamics. I feel like it's because civil engineering kasi yung or at least civil engineering template yung ginagamit usually for NSAI 16, pati naman sa UP Diliman. Pero since may opportunity tayo at that time, sinama ko na rin yung sa airfoil. So, the thing with airfoils is that they are asymmetrical teardrop shapes that because of their shape, nakakapag-generate sila ng lift. Yung mechanics nung lift generation na yun, I think you will be able to look them up sa references natin later. So, ito yung nomenclature ng isang airfoil geometry. So, meron kang tinatawag na chord line, which connects yung leading edge, which is yung nakaharap sa hangin, saka yung trailing edge ng inyong airfoil, which is yung buntot. So, ito supposedly yung chord line na to, this should be the axis of symmetry. Kaso when you start applying asymmetry to the shape, pag tinrace mo yung midpoint line ng bawat vertical slot ng airfoil mo, it forms this curve called the camber line. The camber line expresses yung asymmetry ng inyong airfoil. So, meron pa tayong tinatawag dito na max thickness, max camber. Later sa next slide, makikita nyo na these terms, yung max thickness, max camber, pati yung locations nila, sometimes they're used to label airfoils. Outside of that, another thing that matters is what we call the angle of attack. So, in some references, it's alpha. Sa 171 ba, familiar kayo sa angle of attack? Galing from 171. I believe nag-velocity triangle kayo sa 171. Tama ba? Like ano kaya? So, depending on the reference, nagbabago yung symbol niya. Pero sa airfoil dynamics, usually angle of attack is the alpha. It's the angle of the chord line with respect dun sa approaching wind. So, meron tayong alpha, which is, well, sa amin nun, absolute angle of attack yung paggamit namin na alpha. Pagdating naman sa relative angle of attack, we used beta, believe. Ganun din ba sa inyo? Like, alpha for the absolute angle of attack, plus beta for the relative angle of attack. So, yeah. Nice, at least consistent. Wow. With regards to airfoil terminologies, yung inintroduce sa amin ni Sir Danao na method of labeling airfoils is what we call the NACA terminology. So NACA is siya yung protoform ni NASA, or you can say the pre-evolved form of NASA during that time. So NACA and NASA ay technically sila, parang NASA evolved out of NACA. You can think of it that way. And they had this clever system of labeling airfoils wherein kaya mo nang i-determine yung ilang characteristics out of the name itself. So, meron tayong iba-ibang systems. For now, we'll be just using the 4-digit terminology for NACA. So, yung mga airfoils sa NACA, they usually start out with the label NACA, then 4 digits. Yung first digit, this would be the maximum camber. So, the max camber of the airfoil. And yung second digit would be the location, respective to the leading edge. So, kapag narinig niyo yung term na 4415, so that means yung max camber mo is, I believe, 0.4. Or I'll just get corrected. So, it's either 4 or 0.4. Tapos, yung location nung inyong max camber would be 40%. So, 4415 for 40% of the length from the leading edge. So, 0.4, 40% of the length with respect to the leading edge. Tapos, yung maximum thickness niya would be 15. So, 15 points, 15% of the chord line or chord line. So, yeah. Meron pa ibang systems. They're medyo advanced yung succeeding na dalawa. We'll not tackle it right now, pero they are advantages for certain characteristics. Or oh no, sorry. So, yeah. Ngayon, For airfoils, we have, ang pake natin sa airfoils would be the lift and drag coefficients. These are the normalized values to express yung amount of lift relative to the wind speed, or at least yung quote-unquote force ng wind habang sumasampa siya sa aircraft. So you have the lift coefficient, you also have the drag coefficient, and you also have the CLCD ratio, CLCD curve. The CLCD curve, ito yung representation of, or rather, sa CLCD curve, dun mo nakikita kung saan na ma-maximize yung lift. At least. So yeah. This is the coefficient of lift. So itong curve na to, if you can follow, ito yung sloping up curve, and yung coefficient of drag, this would be the saddle, yung U shape. Although pinutol ng plot na to, yung negative negative angle of attack, it's kind of a U shape here. Oh, by the way, this plot, yung x-axis niya, this is the angle of attack of your airfoil. Ito naman, yung vertical axis, this is the normalized value of your coefficients. So, angle of attack, x-axis, coefficient values ay nasa vertical. So, when you're examining yung characteristics ng aircraft, it's important to note yung point of stall and yung point of alpha zero. So, pag symmetric yung airfoil mo, as in NACA terms, you have zero camber. So, your airfoil is 00XX. Yung lift mo at angle of attack 0 would also be, well, 0. Pero, if you introduce that camber, that asymmetry, kahit na ang angle of attack mo ay 0, positive pa rin yung coefficient mo of lift. Yan nga lang, malakas pa rin yung drag mo. So, as you increase the angle of attack, magkakaroon ka ng increasing returns. So, your lift starts to increase. However, may limit siya. Yung limit na yon is yung maximum point of lift mo, and any further advance in the angle of attack will cause your lift to drop. This is what we call the stall condition. So, kapag nag-stall yung inyong aircraft, it means that yung boundary layer that's enabling the lifting mechanism of your airfoil starts to peel away. So, parang nade-delaminate siya from the surface. So, here sa image na to, you can see sa airfoil na to, this is what happens during stall. The wind layers, the boundary layer of the air or the fluid delaminates very close to the leading edge. So, very close. So, kapag nag-delaminate na yung fluid from the top surface of your airfoil, hindi na siya makapag-generate ng lift characteristics na associated with the airfoil. So, nag-separate na siya completely, and because nag-separate siya, it's causing all these, nagkakaroon ka ng low pressure area, and these eddies, they start to occupy yung low pressure zone na to. Well, of course, kapag nag-stall ka na, you can't generate lift, your plane will start to descend, essentially, no matter what you do. You have to, when you're flying the aircraft, you have to correct, you have to angle your aircraft again such that maka-regain siya no magandang angle of attack. And it's important that as you recover, hindi ka na bumalik dun sa stall region na yun. So in the rightmost plot, it doesn't mean do na kapag naka-maximum lift ka ay walang boundary separation. So even if mataas yung lift coefficient mo at certain angles of attack, may certain delamination ka pa rin. Pero it's important na hindi mag-peel away yung boundary layer ng fluid very close to the start. That's when the problem usually starts. Okay. So any questions ba? With regards to, shit, I keep passing over the tab, sorry. Any questions regarding this? Medyo review lang to, no? Any questions? So, mukhang wala. Okay, let's move on to the next part. Oh, yes. Di ko 'to natanggal. Yun, okay. So now we're going to explore this very weird, software that we call QBlade. So, para din sa mga nagse-thesis sa CFD, um, you may notice na ano, depending on your, conditions, yung mga boundary conditions and initial conditions, very expensive siya computationally. This is why ANSYS has a very high RAM requirement. It needs that RAM to do the computations. And if masyadong mat let's say masyadong mabigat yung hinihingi mo kay ANSYS, your laptop will probably take minutes to render um a single frame. Puwedeng gano'n, puwede siyang mangyari. So, si QBlade, this is a, European sourced na community available software na iba yung ginagawa niya. Hindi niya, ginagamit yung CFD na we normally associate with, fluid modeling, but it uses something that's a little lighter on your software. And it's so good that maganda pa rin yung accuracy niya, pero you don't need that high of a spec computer to conduct complex simulations. So essentially it's a high accuracy software that does not consume so much RAM for your from your computer. So yun. Yun lang. Yun yung main difference niya with compared to ANSYS. So, bakit ba iba? Like, bakit magaan si QBlade sa ating software? So, yung initial iterations ni QBlade, it uses what we call the blade energy momentum theorem. So, si blade energy momentum theorem, may pagka-finite element analysis siya, pero hindi siya CFD or at least hindi siya yung common CFD practice natin per se. Ito yung differences niya. So, yung pagka-FEA niya, yung pagka-finite element analysis niya, it ends with the chopping up of blades into 2D stations. So, imagine mo yung wind turbine, mahaba siya. Try to extend or try to imagine an axis running along its length. Tapos, chinap-chop mo yung blades perpendicular to that axis. So, yun yung discretization ng blade energy momentum na chinap-chop mo yung blades mo into finite 2D sections or finite 2D stations. Hindi siya infinitesimal chops like calculus, pero ano siya, parang medyo blocky na pag-chop-chop. Ngayon, because chinap-chop mo yung blades mo into 2D slices, you can conduct 2D, essentially 2D fluid dynamics on that slice. So, the moment na hinati-hati mo na siya, i-assume mo na 2D flow lang yung nangyayari. So, I believe it's subsonic inviscid 2D flow yung i-assume mo na mangyayari. Which is, well, if naalala niya pa yung from 171, technically hindi yun yung totoo, pero um, may mga corrections kang pwedeng gawin as you assemble the blade back together in your model. Pero yeah, yun yung reason kung ba't magaan yung blade energy momentum sa ating computer. It just computes the 2D flow across a 2D airfoil, essentially. So, ang maganda din is sobrang baba ng computational cost. Like, you can run this on a, kahit below 8 gig RAM na computer and you'll still be able to get a high fidelity result. Pero yun nga, dahil chinop-chop mo yung blade into 2D segments, tapos nag-simulate ka ng flow around those 2D segments, pag binalik mo na sila together, may kailangan kang gawing corrections because, of course, magkakaroon ng another dimensionality to the flow. So, yung old QBlade, yung na-experience namin na-experience namin under Sir Danao 10 years ago. I think 10 years ago ba or 8 years ago. was ano, parang naglalagay siya ng correction factors in order to account for yung three-dimensionality ng blades. Ngayon naman, si QBlade, they're trying to pivot away from BM, although I believe BM pa rin yung ginagamit nila for 2D airflow analysis. It's just when you assemble the pieces back together. I believe dun nagte-trigger yung ano niya, bago niyang method for estimating fluid motion behavior. Pero yes, even in this level, kahit na nag-update na sila, magaan pa rin siya relatively compared to traditional CFD methods like K omega and K epsilon. So yeah. Ang airfoil na estimation system na ginagamit ng QBlade, at least for the 2D slices, is what we call the X-foil. Sa X-foil, napakaluma na niya na program. Sinulat siya using Fortran. If you don't know what Fortran is, yeah, ganun na siya katanda. I don't think na-encounter namin ang Fortran ever. Like, meron kami textbook before sa MA45 equivalent namin. I think it's either Fortran or COMSOL yung language na ginamit. So it's very old. Pero even though it's very old, may meron mga conditions na high fidelity pa rin yung inyong result even though mababa yung computational cost. So like for example here, we have a study done by Morgado et al. In 2016. They tried to study yung fidelity ni X-foil relative to the more expensive ANSYS CFD methods like K omega SST, modded KKL omega, etc. Tapos you can see here medyo okay. Like for a very low computational cost model, um, if you wanna trace it or like nahihirapan kayong makita, yung mga triangles, the triangular plot, yung mountain range, that's the experimental data. Yung black line, that's X-foil. Tapos yung colored na line, the curves, these are the CFD methods that you will often see in ANSYS under the selection. So makita nyo, although may difference pa rin, it's very strong. Like, medyo malapit na siya. And yun yung attractive factor. It is yun yung, very attractive when it comes to X-foil and QBlade is that even though mababa yung inyong computational cost, yung requirements mo on your computer, maganda pa rin yung result. So, this CL over CD plot, medyo mas malapit, I believe, K omega method using low Reynolds na may low Reynolds adjustment, it's close. Pero X-File is not that bad. Like, medyo malapit siya. In terms of pressure distribution or at least sa pressure coefficient, if you look at the rightmost graph, maganda yung performance ni X-Foil compared to everyone else. Si X-Foil kasi ang primary component or this primary value na kinocompute niya is the pressure distribution. So yeah, medyo like with regards to that, kaya siya maganda under when evaluating the pressure distribution along the airfoil. So yeah, even though medyo may pagka-off ng konti yung lift drag characteristics niya, on using under the pressure comparison, maganda like high fidelity CX file. So ginagawa ni X-file is that from the pressure distribution, ine-estimate na niya yung na-generate na lift and drag. So meron mga pitfalls ang X-foil. So to keep track si X-foil, it is programmed directly into QBlade. Yun yung ginagamit ni QBlade to extract lift drag characteristics. So clarification. So X-foil is a separate program but it is directly installed into QBlade. So yeah. So pitfalls ni X-foil na ginagamit ni QBlade, yung ginagawa kasi ni X-foil is that nagdi-discretize din siya ng airfoils. So from the smooth curved surface ng inyong airfoil, ito yung similarities niya with regards to CFD. Sina-chop-chop niya yung yung curves into straight blocky segments. So depende on the resolution of your airfoils, gaganda or papangit yung fidelity ng results nyo. So like for example here sa leftmost graph makita nyo, as you increase yung number of points sa airfoil model mo, uh, lumalapit ka dun sa experimental data. So it gets closer. Tapos if you stay at very low Reynolds, like for example to the magnitude 10 to the 5, gaganda. Like close enough yung model mo compared to the experimental results. So yung mahirap pa sa QBlade or rather sa X-Foil is for higher angles of attack, it starts to deviate a little. So for example here, ito yung previous graph natin sa ang previous slide. Sa CL over CD, you don't notice it kasi you're ratioing two two coefficients. Pero if you compare the lift coefficient to the angle of attack, makita mo yung black line, it starts to kind of deviate a little. Like, meron kang weird peak dito na hindi mo nakikita sa actual na experiment. So, this is for E387 na airfoil. Pero for some airfoils, I don't know if it's because habang tumataas yung eccentricity ng airfoil mo ay nagiging weird yung results. Pero I'm not sure yet. Pero for this airfoil na very eccentric na airfoil, yung black line mo, nagde-deviate na siya habang patas ng patas yung lift coefficient. Like this is the black line. Tapos tandaan natin, yung mountain ridge yung experimental values. It starts to delaminate, quote-unquote, from the experimental data. So, yun lang. Makita mo na sa CLCD, medyo malala. Like, nag-delaminate na siya after CL of 1. Like, nawala na siya ang VT. Like, may siya, nag-overestimate siya ng pressure sa airfoil essentially. Kaya medyo naging weird yung plot. So yeah, even though ganun siya, yung attractiveness niya as a low-cost computational method is still still very high actually. So yeah, okay. Any questions pala about that? Or ano ba? Okay naman kayo so far. Just positive react lang kung okay na kayo. Like no questions, nothing nada. Okay, good. May thumbs up na dalawa. Yes. Okay, so yun. That's 22 minutes. Okay, okay. That's good. Medyo maikli lang. So, mag-start na tayo ng activity natin. Okay. So, right now, if meron kayong QBlade on your desktop, may suggest i-open nyo na siya. Whoosh! Oh, nag-open na. Let me open my own. Yan, okay. So, ito yung QBlade ko ngayon. It's version 2.07.2077. Feeling ko kahit na basta 2 yung version ng QBlade niya, I think it will still work. Yung version na pinlog sa amin ni Sir Dano before was I think version 0. Version 0, version 1. I forgot. Pero hindi siya 2. So yeah, are you, nasa QBlade na kayo? Have you try, ma-open niya na sa inyong computers. Okay, so I'm getting some affirmatives. All right. So, survey question. Based dun sa nakikita niyo sa homepage, alam niyo ba kung saan kayo magsisimula? Here's question. I just need to know. Based on what you see on the homepage, can you tell kung saan kayo magsa-start? Ano sa inyo? So, okay. Yeah, so dito hindi mo malalaman. With regards to QBlade, huh? Meron ba sa inyo na ano, pangit yung download speed sa region ninyo? If ano kayo, nagkaka-issue kayo sa pag-download ng QBlade, if you're here in the campus, pwede kayo mag-drop by sa Amtech office. We have Wi-Fi here, medyo malakas naman. You can download uh, the software through to our Wi-Fi, or pwede kayong bumisita sa regards to activity, hindi naman ano siya, it would be graded, pero hindi siya for submission today. Like, okay lang kahit hindi niya matapos yung activity ngayon or hindi niya siya magawa because of internet issues. Pero this is just for to show you kung ano yung mga pwedeng galawin. Kasi it's this program, although na maganda siya, yung UI niya is very terrible at telling you where to start. So, okay. Para mag-start na tayo, I think I'll be uploading this recording naman. Although, medyo matagal nga. It, I'll upload this siguro in YouTube na lang para like, you can keep track. So, yung first thing na pupuntahan muna natin for this activity would be this button. So, this is the airfoil generation module. Ignore this, ignore that, ignore everything. It's this. Yung airfoil na kulay red na walang pressure distribution curve. So yeah, if you're there, just click on mag-affirmative react na lang kayo if you're there. Okay, it's good. If may kasama kayo na kaklase nyo, kung nasan man kayo, you can help each other out. Pwede kayo mag-isang laptop lang for this. Pwede naman dalawa na rin. But yeah. So this is the airfoil creation region. Ngayon, it's blank. Wala tayong airfoil na naka-upload at all. So dito, ang normal method namin for airfoil generation, I think, kailan ba yan? 2016, so mga 8 years ago. 8 years ago, we had to download our airfoils elsewhere. So pakita ko lang yung I'll show you the website. So nung lumang panahon, ito yung pinupunta namin na website. It's airfoiltools.com. So sa airfoiltools.com, gumagamit na siya ng algorithm to generate yung point by point data points to generate the airfoil. So si QBlade, tumatanggap siya ng .dat files. Pag dinownload mo na siya, tapos you can open your .dat file as an airfoil profile, tapos ma-upload na siya. Ngayon, for QBlade, it seems kaya niya mag-generate ng airfoil, ng naka-airfoil sa loob mismo ng inyong software. So, if you see here, if you right-click on the airfoil generator module, makikita mo, may option sa babang section, nakalagay, naka-airfoil generator. This was not there before. Yeah. This was not there before. So, if you click that, naka-airfoil generator, you will see may dialog box ka. May dalawang inputs. Naka 4-digit and number of panels. So, for our activity, let's stick with Naka 4415. 4415, okay? Tapos, let's try number of panels 100 muna. So, if you do this, 4415 digit, number of panels 100. Ayan, okay. So, may earphone na tayo. Sir, nasan yung data points? Palabas si Naka. Okay. For the Naka, right-click on the space. Tapos dito sa babang section nung right-click menu mo, may makita ka naka-airfoil generator. So, here. Dito ka. Pag nakita mo may prompt, just type the airfoil. So, it's, wait lang. Naka 4415. O 100 panels. Yeah. It's naka 4415, 100 panels muna. So ito yung default view. Kung ayan yung kulay, pwede mo siyang baguhin. Wala lang. Gusto mo blue? Okay, blue. Tapos kung gusto mo dash line, pwede. Tapos pwede mo rin kapalin. Okay. So yan. Kaya lang, ayoko na makapal. So yan. Yan lang. Tapos, you can also show the points. Yung points actually yung isa sa pinaka-importante kasi it gives you an idea kung gaano ka high res yung inyong airfoil. So what you see here in the airfoil generator is that the airfoil generator inside QBlade prioritizes yung leading edge. Marami kasi nangyayari dito, like all of your gains and problems will start here. So ang ginagawa ng QBlade is usually ayaw niyang i-distribute yung data points. Gusto niya na i-bias yung data points here sa leading edge, which is actually a good for this version of the software. Ngayon, dito sa baba, sa Airfoil Design Module, you also see yung foil name na meron tayo. So right now, yung foil name natin is naka 4415. For posterity's sake, let's rename yung airfoil natin. So naka 4415. Tapos, let's rename it as 100 panels. So, P100. Yan. Okay. 4415. So, dito sa baba, may mga columns ka rin. You will see yung naka-label represented here appropriately. So, yung thickness natin, maximum thickness na naka 4415 is the last two digits, 15. So, makita mo dito, your thickness is 15% of the cord length. So, tama, na-preserve. Ngayon, yung first digit natin, it's the maximum camber or the maximum eccentricity. So, this is preserved, this is 4% of the cord length. Pero yung second digit, supposedly, yung camber mo, mangyayari siya 40% of the way sa cord length from the leading edge. Kasi it's not exactly 40% from the leading edge. Okay lang yan. Like, as we generate higher definition panels or higher definition airfoils, makita mong bababago tong column na to. Magbabago-bago siya. Okay? Has everyone generated their NACA 4415? Kahit react na lang, iwan nyo na lang. It's okay. Another thing pala, pwede ka na mag-generate ng center line for whatever purpose. It's okay. Next bit, okay, nakapag-generate na tayo ng airfoil. Let's go to the next module, the airfoil analysis module. Ito yung airfoil na may parang may book or na para siyang airfoil na may imperdible. Wala lang. Okay. So, tada, dito na tayo. So, may makita kayong hanash dito sa kaliwang panel. You have polar controls. This is basically yung file menu nung module na to. So, you can create a new polar. You can delete any polars. You can edit a existing polar or rename them. Yung analysis settings natin, ang nakikita nyo ngayon is yung range ng angle of attack or rather yung domain ng angle of attack na i-examine natin. So, -15 is -15 degrees. Doon magsa-start yung analysis by default. Then, mag-e-end siya at 20 degrees positive angle of attack. Yung discretization ng domain will be 0.5 degrees. So, -15, yung next is -14.5, -14, and so on and so forth. Okay. So, bago natin ito pakialaman, let's create a new polar. Ayan, okay. So, okay lang na i-default mo na lang to. Okay lang to. Um, let's pay attention to the second part of our dialog box. This is the Reynolds and the Mach number. So, For now, let's ignore the Mach number. I've tried to compute yung Mach number for the speeds na kailangan natin. It's not going to be significant. Mga 0.1, 0.2 lang siguro. Pero yeah, it's not gonna be too fast. You can leave it as 0 as is muna. For the Reynolds number, let's try 3 times 10 to the 6. So that's 3 after 6 zeros. So 3 6 zeros. Ngayon, the transition settings, kahit hindi niyo muna siya pakialaman, this bottom box sa ating dialog box has something to do with the exfoil algorithm or exfoil na code. Tinry ko siyang bungkalin kung saan siya exactly nang gumagalaw, pero I haven't been successful. You can try to investigate this. Dahil community software naman ang QBlade, I'm assuming na community software na rin ng Xfoil. So, the code for such evaluation should be discoverable. So, pero you can leave it as default muna, 911 essentially. So, okay. Ito man yung gagawin natin. Like, leave everything as default except yung Reynolds. So, we're going to do 3 times 10 to the 6. So, 3 to 6 zeros. Everybody good? Okay kayo? So, right. Let's click create. Okay. So, ngayon, nag-create tayo ng bagong, nag-create na tayo, pero wala pang laman yung ating, wala pang data, essentially, yung polar natin. So, in order to fill up yung formula, or at least, fill up yung data points natin, we just click start analysis. So, if you click start analysis, kung trip niya rin, you can change the colors din kung gusto niyo. I'm gonna change the colors just to match the color of the airfoil. So yeah, leave this as default muna. Then let's click start analysis. Whoa, okay. So let's click at the points. Oh, okay, okay. Curious ako, ito rin ba yung nakikita niya na 4 plots? Is this the same 4 plots that you see? So what I'm seeing right now is sa top left is lift to angle of attack. Upper right is angle of attack to drag. Bottom left is drag coefficient to lift coefficient. Tapos, yung bottom ko is angle of attack to lift drag ratio. Is this the same thing that you're seeing? I need to ask. Okay, so iba yung bottom to sir, pressure distribution at boundary layer ba sa akin? So yes, yung default ni QBlade is etong dalawa, assist na siya. Pero sa bottom, yes. Um, nung kakabukas ko na ng QBlade ulit, they substituted this with the pressure distribution sa bottom left. Tapos sa bottom right, ito yung boundary layer na drawing. So that's all right. Ngayon, if you want to, let's say see other things in your plot, pwede niya tong i-right click. Like, right click on the graph. Tapos, if pressure distribution, yung nakikita nyo sa, sa bottom left graph, yung naka-check mark is usually the up point graph. Yeah. It's the up point graph. Hold on. Naka-up point siya, yung pressure distribution. If you double click on this, makita nyo yung, options natin. Yeah, this is, pressure coefficient. No, wait. If you right click pala, ano yung nakikita nyo pala na naka-check mark? Dito sa bottom. Like, is it polar graph, up point graph, or airfoil visualization? Airfoil visualization. So, let's click. Ayun, okay. Yan, okay. So, ito na nakikita nyo, no? Sa airfoil visualization. So, this is the lift. So this is negative pressure. This is positive pressure. So right. If you want to change yung laman ng bottom left, you can just select any of these. If you select legend, ito yung mangyayari. So yeah, if you have multiple graphs, mas okay na may legend kayo somewhere. Pero if you wanna use or you wanna compare coefficients of lift, drag, moment, or CL over CD, just select yung polar graph. Select polar graph. Yan. Pag na-select niyo yung polar graph, baka wala pang lalabas. So, para may lumabas, let's double click on this area. So, para makarating kayo this point, select the polar graph dito sa right click menu. Then, double click. Yan. Pagka double click nyo, you will see this. So, you're now free to select or to compare uh, any parameter that you want, essentially. So, for example, for the x-axis, okay, I want to compare the drag coefficient. And for the y-axis, I want to compare the lift coefficient. And ganun. If you want something else, double-click ulit. Let's say gusto ko i-compare angle of attack to the moment coefficient. The moment coefficient is, I believe, yung turning, normalized turning moment na na-experience ng airfoil. So, I select angle of attack as my x-axis, moment coefficient as my y-axis. So, if I apply it, tada. Okay. Tapos, for the bottom right, if I want legends, yeah, I can click legends. So, yeah, okay. Ngayon, ang gusto ko actually tingnan is the lift drag coefficient, lift to drag ratio. So what I'm gonna do with my bottom left graph is I'm just gonna select angle of attack, x-axis, then select lift to drag ratio. If I do that, I have this. So this is the angle of attack. This is the CL over CD ratio. This examines yung maximization ng lift comparison to drag. So you'll find that it's around your best angle of attack will be around 5 degrees. So hindi yung 5 degrees at this is not the peak lift coefficient. Pero ito yung point wherein napakababa ng drag mo compared to lift. So yeah. Can everybody follow? If you're confused, punta lang ka, like you can chat or just raise hands. So yeah, this is the airfoil generation. The thing about it is that, ang ganda ng curves actually. Let's see kung may difference if we increase the panels. So what I'm going to do now is I'm going to return to the airfoil design module. I'm gonna return here. And I'm going to generate a new airfoil. So, nasa airfoil generator module na ako. I right-click, select the naka-airfoil generator, and I'm going to type in the same airfoil, pero I'm going to compare the number of panels. Okay. So, makita niyo may pangalawa ng airfoil. Just to distinguish them from one another, I'm gonna right-click, rename. I'm gonna put 150 panels on this new airfoil. So, ito na siya. You can enter points. Makita niyo may mas dense. It's a lot denser. Yeah. In comparison to our old graph, ito yung detail nung leading edge natin. Ito na ngayon yung detail ng ating leading edge kapag 150 panels. So, you'll see here na mas maraming like it's high resolution na compared to our old one. So now, let's see kung may difference. Sorry, balik tayo sa ating airfoil analysis module. So yeah, airfoil analysis module. Tapos, before you generate a new polar control, make sure nakaselect yung bago mong airfoil. So this is the old one, yung 100 panels natin. I'm going to select yung 150 panels na bago. I'm gonna select new, and then I'm going to apply the same settings. Our Reynolds will be 6 zeros, 3 million, then leave everything else as default. So, okay, yan na. Leave the name din as default. Hayaan lang natin siya. Okay. Ngayon uh, wala pang data pero nag-exist na yung polar data. Now we're just going to click start analysis to start the process. So okay, pag kinlik mo to, let's see kung may difference. Ooh, interesting. Actually, if you use your mouse, pwede ka mag-scroll. This is sobrang weird lang ng controls. Like, zoom in is scroll, zoom out. Medyo weird. So, makita mo, there is some difference. Like, there is. Like, dito sa CL over CD, mom, there is some difference. Pero, if you look here, sa left natin, there's not a lot. Except here. Makita nyo. Dito sa dulo. Like, your graph starts to behave more weirdly. Dito rin, may nakang slight deviations here and there sa lift and drag. It's not, hindi siya ganun ka-obvious kapag lift and drag separately yung kino-compare mo. Pero if you take the ratios, mas halata siya in the CL over CD versus angle of attack. You can see it a little more. So there is some deviation. Like, ang question lang dun is, if you increase the panels, is it more is it better? Like, is it a better fit to the real data? So yung question natin. Right now, hindi ko pa binibigay yung real data. Pero I'll be giving it soon. Yung gagawin niya sa graded activity natin. Pero yeah, this is the result of our activity so far. So, nag-increase lang tayo. Nagdadag tayo ng 50 panels to our airfoil, generated airfoil. There is some slight difference. Let's test pa kung may further difference pa siya down the line. So, if you want, medyo dugyot na method to, pero you can, duplicate the current airfoil. So, yeah, duplicate mo siya, tapos you can name the new airfoil using the number of panels that you want to use. So yeah, like for example, 200. Ayan. 200 na. Tapos doon mo na, i-repanel mo na lang siya. So what I did here was duplicate, make a new name, then I'm going to select repanel. If I select repanel, it's going to ask me for the number of points that I want to implement. So here it's 200. I'm going to click 200 to be sure. Yeah, okay. Yes. So now I have a 200 panel Naka 4415. If you see here yung points natin, may +1 lang siya. Like, of course, it's, these count the points, not the panels. So, you have 201 points here on your new panel. And may hita mo na yung location ng camber, as you increase the number of panels, it starts to get closer dun sa actual label nung inyong airfoil. So, ito yung dati, si 100 panels. Supposedly 40%. from the leading edge yung inyong max. Pero ngayon, as we increase the panels, mas tumataas. Lumalapit siya sa tamang location niya. Ang question lang is, does it actually matter? Like, does it matter? So, yun yung magiging activity, yun yung isasubmit niya activity ngayon. Not ngayon pala, for this week. You're going to compare yung lift drag curves to one another, specifically these three curves. So, lift coefficient, drag coefficient, cell over CD ratio with respect to angle of attack. Compare niya sila. I want you guys to generate hanggang 250. Yeah, hanggang 250 na panel na airfoil. So, I'm gonna leave you at that. Compare nyo yung curves nila. And then, meron akong, well, medyo dugit yung pagkakuha ko ng data. Pero I have experimental data for Naka 4415. Hold on, hold on. Where is it? Wait, I'm gonna share. So I'm going to share this. This is only for the lift coefficient, unfortunately. Pwede ko naman kunin yung drag. Pwede ko na isama dito. Pero yeah, etong data na to, this is very old. This is 1980s pa ata. Pero since it's experimental data, the data still holds, essentially. So yeah, what you'll see here, at most, it's good. Forgive the, long decimals. In-extract ko lang to using a plot digitizer. So it's not gonna be exactly close, pero it's kind of close enough na. So yeah, this is for Naka 4415. For Reynolds number of 3 times 10 to the 6. Ito siya. I'll try to extract yung CD to angle of attack graph din para mapag-compare niya. Tapos, I want you to see if maganda ba yung na-model ng X-foil with respect to the experimental data. So yeah, this activity will be individual. For submission niya is this week. Iko-compare nyo yung lift and drag na model ng QBlade for differing number of panels to an experimental data from the 80s. Comment nyo lang kung meron bang does it really get better as you increase the panels, or meron bang parang is there a point wherein the returns that nagdi-diminish na ba yung returns? Kumbaga, if you increase the number of panels, hindi na siya ah sobrang liit na nung pag-increase ng accuracy niya. So yeah, I'm going to release the details later sa LMS. Pero yeah, that will be your task for this week. Ma-model nyo lang siya. Or this week, you're gonna check yung accuracy ng ating X-foil. It's kind of weird, like bumalik tayo sa curves. Oh my gosh. Napansin ko lang, like, nag-start ka naman sa 4.1 drawing curves. No? Now we're back to examining curves. Pero yeah, yun. I guess the irony is present. Pero yeah, if may questions kayo on QBlade, you can explore pa further. Ngayon, we're going to go into a module na hindi part nung inyong exercise. Dahil pantawid natin to dun sa blades. So, this is the polar extrapolation module. This is important specifically for turbines, not for planes per se, pero for turbines. Kasi the turbine is being exposed to 360 degrees airflow coming from 360 degrees. Oh, we have a question. Sir, hanggang 250 panels lang po. Yes, hanggang 250 na lang. If you want to be extra, you can increase yung tawag dito. resolution ng panel. No, no, not, I mean, yung discretization ng panel sizes. Like, you can explore um, 240 to 30. Pero I would say, 100, 150, 200, 250. If you want, you can, kung feeling nyo warranted, you can go for 290 panels. Yun yung limit ni QBlade at the moment. So, yun lang. Apat lang na panels. So, 100, 150, 200 to 50. Compare niya. So, ngayon, uh, again, itong 360 module is not part of the graded activity, pero this is important for examination of the turbine. Kasi itong 360 degrees extrapolation, ito yung ipapatong-patong nyo as you reassemble the blades. So if you recall, yung method ni QBlade is chop-chop-chop niya yung blades into 2D segments, tapos i-reassemble niya yung blade along with the 2D data. So, this extrapolation is a part of that. Ito yung actually i-reassemble mo when you're assembling the blade. So, for example, like select yung 100 panels natin. So, yeah, right now, nilimit natin yung angle of attack natin, yung angle of attack examination natin to negative 15 and 20. That's because yung limits nung pag-model ng X-foil is very small range lang. It's enough na such that yung stall behavior, mako-cover mo na. The rest kasi hindi na siya ganun ka-significant when it comes to aircraft behavior. Pero here, we can extrapolate. Gawin natin siyang 360 degrees essentially. So to do that, meron tayong two algorithms, we have Montgomery and Viterna. Kahit Montgomery na lang or you can try Viterna. Pero right now, hindi natin siya kaya i-in-depth kasi we are not equipped to tackle yung details ni Montgomery sa Viterna method for extrapolation. Pero if you click extrapolate, this is what happens. The So yes, ito yung makikita niyo pag nag-extrapolate kayo. The blue line is yung data na na-generate ni Xfoil and yung red lines dito, yung red extensions, this is the extrapolation na ginawa nung ating formula. So here para siyang it's kind of like a spline. You can control bits of the polar, pero we will not dabble in this right now. The default option is good enough for us. Hindi naman tayo gumagawa na actual na turbine para yan. This is what you will be saving when you want to generate blade turbine blades or turbine rotor performance characteristics. So, yan lang. Any questions about this? Let me check lang yung task manager. So right now, my QBlade is occupying 52 MB of my RAM. So 52 MB lang siya right now. Let me try if I can get yung uh, let me try if I can get a snapshot kung gaano ka if this part actually generates a lot of memory consumption. No, it does not. 52 MB lang siya. For context, Discord is consuming twice the memory for this task. So it's very low cost. It is low cost. So advantageous to when you're examining turbine blades tapos you don't have the extreme software for that task. Ngayon, if we go back to our slides, this study in 2016, they tried to explore or compare yung performance ng X-foil kay QBlade na ginagamit ni QBlade with regards to CFD. Medyo okay naman siya for non-peaking lift data. And it's better for pressure estimation along the cord of the airfoil. So yeah, magaan siya. Like, to be honest, like nagulat ako ng sobrang gaan niya. This is the first FEA software na binigay sa amin. Like, hindi ANSYS yung nauna sa amin. It's this one. So yeah. Unfortunately, hindi niya kaya mag-examine ng propellers. So if you're leaning towards that, hindi niya kaya. Pero like for example, if you want to model blades, like for example, if no, not blades. If you wanna model a windmill na naka-buoy sa ocean, like for example, it's naka-tether lang siya at the surface of the ocean, you can model its behavior essentially as it operates. I believe it's steady state behavior though. I don't think it can do transient. Pero yeah, medyo abot na niya. Yung ganong type of simulation for a very low computational cost compared to CFD. So yeah, if no more questions, isasend ko na lang yung further details ng activity later. Tapos I'll upload din yung experimental data from that 1980 source in a bit. So yeah, probably yung submission nito would be, I think Friday. I'm not sure. It would be Friday. Hold on, let me just stop the recording.